Hi everyone, this is in this lecture we are going to study the introduction here, right? Okay, so the first topic we are going to cover. So in the previous lecture I have given what are all the topics that we are going to cover. So in this lecture we are going to start with the first topic, that is introduction, right? Okay, so the first topic that is introduction. Right. So here I am going to tell you what is the importance of this electric field and magnetic field and these electromagnetic waves. So that's what we are going to briefly discuss about these things, right? Okay. Okay. So I am going to start this lecture with forces here. I am going to start this lecture with forces, right? In nature I can categorize the forces. In nature I can categorize the forces into two types. So one is a contact forces, one I can call them as contact forces, and the other I can call them as a field forces. So I can categorize the forces into two types. One is contact forces and other one is a field forces. So what do you mean by contact forces here? See, this type of forces we are very much familiar. So if you want to push or pull, any object, so how you are going to do that? You are going to do that through contact only. Yes or no? So if you want to push a person, or if you want to pull a person, or if you want to push any object, or if you want to pull any object, okay, then you are going to apply the force through only contact. So this type of forces we call them as what? Contact forces. So we are very much familiar with this type of forces here. See, for example, all mechanical forces will come under what? Will come under this contact forces, right? All mechanical forces will come under this contact forces, right? And in nature we are having another type of forces which are called as field forces, See, the beauty of this field forces is they can exert the forces on the external matter without any physical contact. So they can exert the forces without any physical contact. They can exert the forces on the external matter. So those forces are called as field forces. So what is the beauty of this field forces here? The beauty of this field forces is they can interact with the matter, or I can say they can exert the forces on the external matter over longer and longer distances without any physical contact. So that is the beauty of this field forces, right? So in nature up till now we have discovered four types of field forces here. So up till now in nature we have discovered four types of field forces. So what are those field forces we will see, right? Okay. So the first one, so here we are having four types of field forces. Up till now in nature we have discovered four types of field forces. So what are those four field forces we will see? So the first one is a gravitational field force. The first one is gravitational field force, and the second one is a electromagnetic field force. So third one is nuclear force. Fourth one is also nuclear force. So this nuclear force is categorized into two types. So one is a strong nuclear force and the other one is a weak nuclear force. See, the applications of strong nuclear force is different and the applications of weak nuclear force is different. So that's why we have divided again this nuclear force into two types. One is strong nuclear force and other one is weak nuclear force, right? So these are the four field forces that we have discovered in nature up till now. Okay, so since these are the basic forces that we have discovered, these are the basic field forces that we have discovered in nature, so that's why these are called as basic forces of nature. So these are called as what here? These are called as basic forces of nature. These are called as basic forces of nature. So in this basic forces of nature, we are going to concentrate, or we are going to study about this electromagnetic field forces. Right? Among all these basic forces of nature, we are going to concentrate on the electromagnetic field force. Right? See, when compared to all the other three forces here, our electromagnetic field force is having one peculiar property. So what is that peculiar property here? Can you guess that? What is the peculiar property? So our electromagnetic field force is having a peculiar property when compared to all the other three forces. So what is that peculiar property? Can you guess that? See here, if you observe all the other three forces, they are going to have only the property of attraction. Yes or no? Whereas this electromagnetic field force is going to have what? It is going to have both the properties of what? It is going to have both the properties of attraction as well as what? Attraction as well as repulsion. Right. So this electromagnetic field force is going to have both the properties of what? It is going to have both the properties of attraction as well as repulsion. So when compared to all the other three forces, are going to have only the property of attraction. Only our electromagnetic field force is going to have both the attraction as well as what? As well as repulsion. Okay. So that is the beauty of our electromagnetic field force. Right? Okay. So now see here. So previously, in olden days, whenever they have discovered this electric field and magnetic field, so at that time they have thought that this electric field and magnetic field, they have thought them as two different phenomena. Okay, so that means they have treated the electric field separately and magnetic field separately. So they don't know the relation between electric field and magnetic field. So this is the situation initially. Understood? Okay. So if you ask a question, sir, whether this electric field and magnetic field, can we treat them as two different phenomena, or is there any relation between electric field and magnetic field? So if you raise that question, my answer is this electric field and magnetic field can be treated as two different phenomena whenever we are dealing with static spot here. Whenever we are dealing with the static fields. So static fields means what here? The fields are not varying with respect to time. So in that case, we can treat the electric field as a separate phenomena and magnetic field as a separate phenomena. So their assumption is correct if this assumption is correct whenever we are dealing with static fields. Understood? Okay. So whenever you are dealing with static fields here, so that is electrostatic field and magnetostatic field. So static field means what here? Fields are not going to vary. Fields are not going to vary. Fields are not going to vary with respect to time. So under this condition, we can treat the electric field and magnetic field as what? As two different phenomena. We can treat them as two different phenomena. Okay. But whenever we enter into time varying case, so that means whenever this electric field becomes a function of time. See, electric field is also a function of what? Space. It is going to vary spatially. Yes or no? So it is already a function of space. Now it has become a function of time also. So whenever the electric field becomes a function of space as well as time, it is observed that this time varying electric field is going to produce a time varying magnetic field. See, this time varying magnetic field will also vary with respect to space here. Understood? So here electric field and magnetic field are functions of both time as well as what? as well as space. So whenever you are having a time varying electric field, so it is observed that it is going to produce a time varying magnetic field. See, whenever I am saying simply time varying, you have to understand that it is also spatially varying. Understood? So in general, if you consider static fields also, the fields are going to vary with respect to space. Understood? The electric field and magnetic field in general are functions of space, right? Now, if you vary these fields with respect to time, what happens? That's what we are going to see here. Okay. So whenever the electric field, whenever you are having a time varying electric field, it is observed that it is producing a time varying magnetic field, and this time varying magnetic field in turn is producing a time varying electric field, and these two together, one is producing the other, and they are traveling through what? And they are traveling through what? Traveling through space, and they are traveling through space, which we call them as electromagnetic waves, So that means whenever we enter into electromagnetic waves, guys, part, okay, so there the time varying electric field is going to produce the time varying magnetic field, and this time varying magnetic field in turn is going to produce the time varying electric field. So one is going to produce the other, and they are going to travel through space, which we call them as electromagnetic waves. Understood? So once we enter into electromagnetic waves part, we cannot treat the electric field separately and magnetic field separately. So we cannot treat them as two different phenomena. Why? Means here one is producing the other. One cannot exist without the other. So if H field ceases to exist, then electric field will also ceases to exist. Okay, so why? Means here one is producing the other. They will always coexist together. They cannot exist separately. Understood? So just like Romeo and Juliet, they will always coexist together. In case of what? In case of electromagnetic waves. Understood? Okay. Okay. So here in this case, in electromagnetic waves, we cannot treat the electric field and magnetic field as two different phenomena. Instead, we have to treat them as a single phenomena. Understood? Okay. So in electromagnetic waves case, here we have to treat electric field and magnetic field, we have to treat them as what? As a single phenomena. They will become a single phenomena. Understood? Okay. Okay. So now here the credit for the discovery, or I can say the credit for the prediction here, for the prediction of the existence of these electromagnetic waves will goes to the hero of our subject. Right? What I am saying here is the credit for the prediction of these electromagnetic waves will goes to the hero of our subject. So who is the hero of our subject here? The hero of our subject is nothing but, is none other than James Clerk Maxwell. So he is the hero of our subject here. He is the hero of our subject. Okay. So the credit for the prediction of the electromagnetic waves will goes to James Clerk Maxwell, and he is the hero of our subject. So you will understand what is the efforts, or what is the credit that this Maxwell has given for the discovery of what? For the discovery of this electromagnetic waves, and all those things we will see as we proceed into the subject. Okay. Okay. So now see here. So he is the hero of our subject, that is James Clerk Maxwell. So what he has done is he formulated all the laws of electromagnetism into 4 simple mathematical equations, which we call them as Maxwell's equations. And from those Maxwell's equations, he predicted the existence of electromagnetic waves. Okay. So what he has done here, James Clerk Maxwell, he formulated all the laws of electromagnetism into 4 simple mathematical equations, which we call them as Maxwell's equations. So from those Maxwell's equations, from those Maxwell's equations, he predicted the existence of electromagnetic waves, right? So not only he predicted the existence of electromagnetic waves, but also he predicted that these electromagnetic waves are traveling. He also predicted that these electromagnetic waves are traveling with the speed of light. That is c meters per second. In free space. Okay, so what Maxwell has done, he formulated all the laws of electromagnetism into 4 simple mathematical equations, which we call them as Maxwell's equations. So from these Maxwell's equations, he predicted the existence of electromagnetic waves. So not only predicted the existence of electromagnetic waves, but also he predicted that these electromagnetic waves are traveling with what? Are traveling with the speed of light in free space. So not only in free space, right? Okay, so if the light is electromagnetic waves are traveling with the speed of light. See, if the electromagnetic waves are traveling with the speed of light means light is also a form of what? Light is also a form of electromagnetic wave only. Yes or no? Okay, so here we have discovered that light is also a form of what? Is also a form of electromagnetic wave only. So not only light here, so you can say X-rays, gamma rays, right? X-rays, gamma rays, radio waves. I am not writing in order here, so just I am writing all the different types of electromagnetic waves I am writing. So X-rays, gamma rays, radio waves, right? And then infrared rays, visible light, UV rays, etc. So all these are nothing but what? All these are also nothing but electromagnetic waves only, and all these are traveling what? All these are traveling with the speed of light in free space. So not only light here, X-rays, gamma rays, radio waves, infrared rays, visible light, UV rays, etc. all these are also nothing but electromagnetic waves only, right? And all these are traveling with the same speed, that is speed of light in free space. Understood? Okay. So this is the discovery they have done later, right? Okay, so now see here. So all these are nothing but what? All these are nothing but electromagnetic waves only. Sir, you are saying all are electromagnetic waves, but if all are electromagnetic waves, then why we have named it differently? See, the characteristics of the electromagnetic waves are changing depending upon the frequency range. So that's why we have named it differently. See, in one frequency range, they are acting like X-rays. In some other frequency range, they are acting like gamma rays. In some other frequency range, they are acting like radio waves and so on. And in some other frequency range, they are acting like visible light and so on. Right? Okay. So depending upon the frequency ranges, the characteristics of the electromagnetic waves is changing. So that's why we have named differently in different frequency ranges. Okay. Now comes the question: if we have named differently in different frequency regions, then in our subject, in which frequency region we are going to study about the electromagnetic waves? So this is the doubt you may get. So here in our subject, we are going to study the electromagnetic waves. We are going to study the electromagnetic waves in the range of what? In the range of radio waves frequency range. Understood? So these radio waves are going to use for what? These radio waves are going to use for communication purpose. These radio waves are going to use for communication purpose. isn't it? Okay, okay. So in our subject, we are going to concentrate, or we are going to study about the electromagnetic waves that are present in the radio wave frequency range, which are used for what? Which are used for communication purpose, right? Okay, okay. So I hope this is crystal clear. And one more thing here you have to understand is, here all these are nothing but electromagnetic waves only, and all are traveling with the same speed, that is with the speed of light in free space, right? And these electromagnetic waves are distributed over a large frequency range. Ideally speaking, the frequency range is from 0 to infinity. So ideally, so this is ideally here. So ideally speaking, these electromagnetic waves are distributed from 0 to what? From 0 to infinity frequency range. Understood? Okay. So since all are nothing but electromagnetic waves, and these all electromagnetic waves are distributed over a frequency range, so we call this as what? We named this as a electromagnetic spectrum. We name this as what here? Electromagnetic spectrum. So why we are calling it as electromagnetic? Because all these are nothing but electromagnetic waves. And why we are calling it as a spectrum? Because these electromagnetic waves are distributed over a large frequency range. So a frequency range generally we will represent with spectrum. Okay, okay. So that's why they have named it as a electromagnetic spectrum. And if you observe, in electromagnetic spectrum, we are having what? We are having visible light also, right? Okay, and you are having radio waves also, right? So can we imagine our lives without this visible light here? And can we imagine our lives without this communication here? Without this radio waves, there will be no communication. Understood? Okay. So that means each and every electromagnetic wave is having its own importance. So it is very difficult for us even to imagine our existence without this electromagnetic spectrum, isn't it? So that is it is very difficult for us to imagine our lives without these electromagnetic waves. So that is the beauty and the importance of these waves in our daily life, right? Okay, okay. So I hope you have understood the importance of these electromagnetic waves, right? Okay, okay. So this is the basic here. This is the basic subject that you have to study. See, from this subject only all the other subjects were developed, right? Okay. See here, without electric field and without magnetic field, there will be no voltages and currents, isn't it? Okay. So without electric field and magnetic field, there will be no voltages and currents. Without, okay. So without electric field and magnetic field, there will be no voltages and currents. Yes or no? So if there is no voltages and currents, right? So then you cannot have a single subject in ECE without these voltage signals and current signals. So whatever the signals that you are studying, okay, whatever the signals that you are studying, they are nothing but voltage signals and current signals only. So in all the technical subjects of ECE, we are going to deal with what? We are going to deal with these voltage signals and current signals. So these are not possible without what? Without these electric fields and magnetic fields, right? Okay. So there exists no single subject in ECE stream without these voltages and currents. So these voltages and currents are possible because of what? Because of these electric fields and magnetic fields, right? Okay, okay. So that is the importance of these electric fields and magnetic fields and these electromagnetic waves and all these things, right? So I hope you have understood the importance of this subject, right? Okay, okay. So this is the importance of this subject in our daily life also, right? Okay, right? Okay. So next I will end up this session with a last saying, that is God has written God has written God has written God has written the nature in the language of mathematics. Okay, so this is the saying by Galileo here. So I hope you know Galileo, yes or no? Okay, so what Galileo has told is God has written the nature in the language of what? In the language of mathematics, right? So that means whatever that is happening in nature, that we can interpret in terms of mathematical equations, or that we can represent in terms of mathematical equations. See, for example, if I write E is equal to mc square, so this is some mathematical equation, but this mathematical equation is saying about the phenomena that is occurring in nature, yes or no? So what this equation is saying here? It is saying that the energy can be transformed into mass, and mass can be transformed into energy. So this is the phenomenon that is occurring in nature. So whatever that is happening in nature, we can easily interpret, or we can easily represent that in terms of what? Mathematical equations. Understood? So that's why Galileo has told that God has written the nature. God has written the nature. That means whatever that is happening in nature, we can represent in the language of what? Mathematics. So whenever you are writing some mathematical equation, so it is saying something about the phenomena that is occurring in nature. Understood? Okay, so in our subject also here, we are going to deal with what? We are going to deal with the mathematical equations. Understood? Okay, like Maxwell's equations and all those things. So those Maxwell's equations are going to tell you something about that is happening in nature. So if you interpret that, okay, if you understand what those Maxwell's equations are saying about the phenomena that is occurring in nature, then you can easily understand those Maxwell's equations. See, without physical interpretation of the Maxwell's equations, you cannot understand this subject. Okay, so the physical interpretations of these Maxwell's equations are very, very important. So in order to understand this mathematical Maxwell's equations and all these things, first of all, you have to build some mathematical foundation here. So that's why in the next lectures, what I'm going to do is, for the next few lectures, I'm going to build a strong foundation for you, a strong foundation of mathematics, that is needed. Don't think that we are going very deeply into mathematics. That is not needed. Okay, so we are going to study the mathematical part that is needed for us to understand this subject. Understood? So generally in this subject, we are going to deal with what? We are going to deal with electric fields and what? And magnetic fields, which are nothing but what? Which are nothing but vector quantities. Right? And also we are going to deal with the operations like gradient, divergence and curl. So these are nothing but vector operations. So throughout our subject, we are going to deal with the vector quantities and vector operations. So in the next few lectures, you have to understand how to deal with the vector quantities, and also you have to understand how to deal with the vector operations, and what are the physical interpretations of these vector operations. So if you understand all these things here, then you can easily understand, or you can easily learn this subject in an effective manner, right? Okay. So that's why for the next few lectures, we are going to concentrate on the basic mathematical part that is needed for us to understand this subject in a crystal clear manner, right? Okay, so I hope you have enjoyed this lecture up till now. So this is the brief introduction, right? Okay, so here I have told the importance of electric field, magnetic field. So without electric field and magnetic field, there will be no voltages and currents. So without voltages and currents, you cannot have a single technical subject in EC stream, right? And also without electromagnetic waves. We have seen the importance of the electromagnetic waves, yes or no? Without electromagnetic waves, it is very difficult for us even to imagine our existence. Understood? Okay, so that is the importance of this subject. So that's what we have studied here, right? Okay, okay. So from the next lecture onwards, we are going to start with the basic mathematical part, right? So in the next lecture, I will start with the basics of vectors, right? So with this I am ending up this session. With this I am ending up this session, right? Okay, so I hope everything is crystal clear, right? Okay, right? Okay then, thank you, take care, bye bye.